Some outboards you remember because they got you home. Others you remember because they left you drifting 40 miles offshore, waiting for a tow. When you buy an engine, you expect it to last, not to catch fire, seize up, or need a $6,000 supercharger before it hits 1,000 hours. So today we're counting down the worst outboard engines ever made. Design flaws that bankrupted owners, manufacturing defects that killed companies. And number one on this list destroyed a company that has been building engines since 1885. Shopping for a used rig? Already own one? This could save you thousands. Number 10. Suzuki DF 140 and DF 154 stroke, 2002 to 2008. The lower unit pinion. Bearing fails between 300 and 500 hours, contaminating the entire oil system with metal shavings. The water pump housing had casting defects that caused internal corrosion and cooling failures. The fuel pump relay would fail randomly, shutting down the engine mid-run with zero warning. If you've ever heard a lower unit start to growl and then go quiet, you know that silence is not peaceful. It's the sound of expensive metal turning into loose glitter. On these Suzukis, the failure wasn't a freak event. It was practically a scheduled feature. Owners would take meticulous care of them, change oil religiously, baby the throttle, and still end up with metallic paste in the gear lube. And a mechanic saying, "Yeah, we see this a lot on these. These engines sell for $2,500 to $4,000 today." But parts availability collapsed after Suzuki discontinued marine support in several regions by 2015. Repair costs run $3,500 to $5,500 for lower unit work alone. One owner got towed in 3 times in 2 months before discovering the shift shaft had failed completely and no replacement parts were available within 200 miles. Another owner bought a pair of low-hour, dealer-maintained DF-140s for what seemed like a steal. On the sea trial, they shifted fine and idled quiet. 2 trips later, one unit started slipping in and out of gear under load. By the time a mechanic got the lower unit off, the pinion bearing was shattered, the gears were chewed, and the estimate to rebuild one side was more than he'd paid for both engines. The quiet, refined 4-stroke he'd wanted turned into the most expensive noise he ever heard. You bought the quiet alternative to 2 strokes and ended up with an engine that wouldn't shift into gear 20 miles offshore. But if lower unit failures sound bad, the next engine cracked its own block. Number 9. Honda BF75 and BF94 stroke, 2000 to 2006. Head gaskets fail between 200 and 500 hours, mixing coolant with oil and warping cylinder heads from thermal stress. Thermostats fail closed, trapping heat and causing repeated overheating. Cycles. Some blocks actually cracked from the stress. Cooling passages were undersized for saltwater environments. Honda built its reputation on reliability. The cars, the generators, the lawnmowers, they just ran. When Honda entered the marine market, boaters expected that same reliability. What they got was an engine that literally cooked itself alive. The irony was painful. An outboard that overheated because it was too advanced for its own good. Clean running examples sell for $1,500 to $3,000, which seems cheap until you face the $3,500 to $6,000 head gasket repair, or the $8,000 to $10,000 engine replacement. Honda parts come at automotive prices marked up for marine applications, and many mechanics won't touch them because they lack experience with Honda marine engines. One owner followed every service interval perfectly and still watched coolant bubble into the oil pan at 420 hours. Warranty denied for inadequate maintenance. Another boater said his pair of BF90s ran great for 2 seasons. Then both started running hot at idle. After a thermostat replacement and 2 coolant flushes, the issue got worse. When the heads were pulled, both had warped so badly that the mechanic said machining wasn't worth it. He repowered with Yamahas and called the Hondas the most expensive lesson in brand loyalty I ever bought. Honda reliability was the reason you bought it. Then you realized that myth didn't transfer to their marine division. And if cracked blocks seem extreme, the next engine made intermittent failures a full-time job. If this is already changing how you look at used outboards, hit subscribe so you don't miss the next breakdown we do on engines dealers. Would rather you never research. Number 8. Mercury Mariner Optimax. 1. 35 to 150. Horsepower. Early 2000s. The air compressor that forces fuel into cylinders fails around 400 to 600 hours at $3,000 to replace. Oil injection pumps quit without warning and seize pistons. The engine control module dies randomly, the engine won't start, you get towed in, then it fires right up at the dock and runs perfectly until you're 5 miles out, and it dies again. These engines were Mercury's attempt to bridge old-school two-stroke punch with new emission standards. Instead, they created a machine that required a degree in computer diagnostics and the patience of a saint. Ask any mechanic who worked during the early 2000s, and you'll hear the same phrase. Optimax means optional maximum reliability. These sell for $3,000 to $6,000 depending on hours, but factor in another $2,500 to $6,000 in looming repairs. The ECM alone costs $1,800. Fuel injectors clog with ethanol, vapor separators fail, and the mid-range stumble that 3 different mechanics can't diagnose will cost you $4,200 in parts before someone finally guesses it's the air compressor. One owner had the same engine towed in 4 times in 6 weeks. Each time it ran fine at the shop, died offshore the next weekend. Another described it as a slot machine on the transom. Every time you start it, you're gambling with your wallet. If random failures sound maddening, number 7 turned cutting-edge technology into a parts-swapping nightmare. Number 7. Yamaha HPDI, 200, 225, and 250 horsepower, 2000 to 2007. High-pressure direct injection promised 2-stroke power with 4-stroke efficiency. Instead, the high-pressure fuel pump fails between 400 and 800 hours at $2,800. The air compressor quits, injectors fail, and wash cylinders, scoring pistons. The engine management unit controls everything. When it dies, nothing works, and replacement costs $1,500 to $2,200. Running examples sell for $4,000 to $8,000, but owners report spending that much again in the first year chasing electrical problems. Oxygen sensors trigger limp mode. Carbon buildup requires expensive cleaning. Saltwater corrodes electrical connectors and creates phantom issues that send mechanics down diagnostic dead ends. One owner went through 3 Yamaha dealers trying to find someone who could permanently fix an idle problem after $6,200 in parts. The problem was still there. Another had both HPDIs on his offshore boat, replaced after 800 hours, when the injectors washed out the cylinders on both engines in the same month. Yamaha's most complex 2-stroke became their least reliable, and the irony wasn't lost on owners who'd paid premium prices for technology nobody could fix. Now let's talk about the engine that used a belt in a marine application. Number 6. Mercury 3.0 liter EFI. 4-stroke, 200 to 250 horsepower, 2000. 2 to 2004. Mercury used a timing belt instead of a chain in their first large 4-stroke platform. The belt needs replacement every 300 to 400 hours at $1,200. Miss that service and the belt snaps valves meet pistons, and you're looking at $6,000 to $9,000 in damage. Oil consumption runs 1 quart every 10 hours. Valve guides wear prematurely. Cooling systems overheat. Throttle bodies fail. These flood the used market at $3,000 to $7,000 because owners are bailing out before the belt snaps. Most engines never reached 1,000 hours before needing major work. Mercury discontinued the entire platform and started over with the Verado design. One owner asked his mechanic what happens if the belt breaks at full throttle. The mechanic didn't need to answer because it had just happened at 7,200 RPM 30 miles offshore, and the repair estimate came back at $8,400 on a boat worth $6,000. Another owner said he loved how smooth and quiet it ran until it suddenly didn't. After the belt broke and the pistons bent valves, he said the repair quote made him laugh, not because it was funny, but because it was cheaper to sell the whole boat for scrap. You learned an expensive lesson about timing belts in marine engines. But belt failures only cost money. The next engine caught fire. Number 5. Johnson Evinrude E-TEC. 40 to 60 horsepower, 2007 to 2012. Engine fires were reported while running and while parked at docks. Fuel system leaks developed near hot exhaust components and ignited. The engine management module fails constantly at $2,000 per replacement. Some engines burned through 3 or 4 under warranty. Injectors quit. Fuel pumps die. Air temperature sensors trigger limp mode. Starting relays leave boats stranded. Running examples sell for $1,200 to $2,800, which tells you everything about their reputation. After warranty ends, each major failure costs $3,500 to $5,500, and boats sit for weeks waiting for back-ordered parts from Bombardier Recreational Products. One owner smelled fuel at his dock, went inside for coffee, and came back to flames shooting from the cowling. The fire department saved the boat, but the E-TEC was a melted hunk of aluminum. Another said his pair of E-TECs looked futuristic, sounded great, and idled whisper quiet, until both refused to start one morning because the EMMs had fried overnight. The dealer blamed voltage spikes, replaced them, and a year later it happened again. Bombardier quietly discontinued these years before killing the larger E-TECs, and they never explained why. The environmentally friendly engine that caught fire and leaked fuel into the water. But fires only affected some owners. The next brand betrayed everyone. Number 4. Force Outboards, all models, 1988 to 1995. Force was leftover Chrysler Marine parts, rebranded and sold through United States Marine and Sears. Mercury's parent company owned U.S. Marine. When Chrysler exited Outboards, someone slapped a new name on old inventory and sold it cheap to protect Mercury's premium pricing. Every model 40, 50, 90, 120, 125 horsepower was built with the cheapest components possible. Castings were rough. Hardware was bargain bin quality. Corrosion protection was an afterthought. These engines weren't engineered from scratch. They were assembled from whatever was left on the shelf. Running force engines sell for $200 to $500 maximum because everyone knows what happens next. Carburetors fail and never really stay in tune. Lower units leak gear oil and eat themselves if you forget to check the lube every few trips. Ignition systems quit in humidity. Fuel pumps last one season. Recoil starters break. Plastic parts shatter in sunlight. Control cables bind. Tilt and trim units stick or bleed down overnight. What looks like a simple two-stroke turns into a stack of parts on the dock every spring. One owner said his 50-horse Force ran great right up until it didn't. He spent more time replacing coils, starters, and impellers than actually using it. Another tried to find a water pump impeller in 1999 and was told by 3 dealers, "You'd have better luck finding one on eBay." A third owner bought a clean-looking bow rider with a Force 90 on the back, thinking he'd scored a deal. By the end of the first year, he'd replaced the stator, voltage regulator, starter bendix, and gear case seals. Then watched the exhaust housing crack from corrosion. The hull was fine. The motor was a parts diagram come to life. Mercury killed the brand in 1995, and parts support ended immediately by 2000. Finding components was almost impossible, and mechanics refused the work. Many shops put a sign on the wall, "No Force, no exceptions." One owner saved $800 buying Force instead of Mercury, spent $2,400 over 5 years keeping it alive, then sold the entire boat for $1,500 because nobody wanted a rig with Force on the back. Perfectly good hulls rotting in yards because repower costs exceeded boat values. Those are tombstones for bad decisions. Corporate betrayal is one thing. Force was cheap by design, and everyone who touched it paid the price. But number 3 took the opposite path. Premium technology, premium price tag, and failure modes just as catastrophic. Number 3. Mercury Verado 4-cylinder. 150 to 200 horsepower, 2004 to 2010. Supercharged, intercooled, fuel-injected 4-stroke technology with power steering on an outboard. The supercharger fails between 600 and 1,000 hours at $4,500 to $6,000. The intercooler corrodes internally, leaks, and allows salt water into the engine. Low-pressure fuel pumps fail. High-pressure fuel pumps fail differently. Vapor separators quit. Throttle bodies die at $800 to $1,200. The powertrain control module costs $2,800 when it fails. Used examples sell for $6,000 to $12,000. But out-of-warranty repairs commonly hit $6,000 to $12,000 in a single failure event. Wiring harness corrosion creates electrical nightmares. Trim senders fail. Sensors die constantly. Some owners had superchargers replaced 3 times. One owner heard the supercharger whine, turn into a grinding shriek. Then smoke appeared, then silence. The estimate came back at $7,600 on an engine with 780 hours that had already consumed 3,400 in repairs. One mechanic said it best: "When Verado runs, it's the best engine on the water. When it doesn't, it's the most complicated paperweight Mercury ever built." The most expensive outboard to buy became the most expensive to maintain, and Verado 4-cylinder became a warning instead of a badge. But superchargers only destroyed wallets. The next engine destroyed companies. If you'd never trust one of these on your transom after seeing this, drop a like and tell me in the comments which engine you'd walk away from immediately. Number 2. Johnson, Evinrude. 3.3 liter V6, FICHT ram, 90 to 250 horsepower, 1996 to 2006. Outboard Marine Corporation bet everything on direct injection technology that wasn't ready. The 3.3-liter FICHT ram V6 was supposed to deliver 2-stroke power with 4-stroke efficiency and cleaner emissions. Instead, engine management modules failed at $2,500. Each owners replaced them multiple times. Injector tips melted under high pressure, causing detonation that melted pistons and punched holes in cylinders. Fuel rail sensors quit. Air temp sensors died. Throttle position sensors gave false readings. Power packs failed. Stators left boats stranded. Water pump housings corroded. Exhaust systems dissolved in salt water. On launch, these engines came with glossy promises. Better fuel economy than carbureted motors, no oil smoke, modern electronics, the future of 2-stroke power. In the field, they delivered random shutdowns, lean conditions that torched pistons, and warranty departments drowning in claims. Dealers stacked dead powerheads behind their shops because there wasn't enough time or money to rebuild them all. Some engines never made it past 200 hours before catastrophic failure. Others were updated with factory kits that bought a little time but never fully solved the underlying design problems. 200 horsepower FICHT engines sell today for $500 to $1,000, and many are given away free just to get them off transoms. Average ownership cost $8,000 to $15,000 in repairs before owners gave up. Many engines were scrapped under 500 hours. A charter captain who tried running twin 200 FICHTs reported losing a full season after back-to-back EMM failures and a melted piston, then took a loss repowering with conventional carbureted motors just to make his boat reliable again. Owners on forums still swap horror stories. One went through 4 EMMs and a seized powerhead before he finally repowered. Another said his pair of FICHTs ate themselves alive like piranhas in the bilge. The saddest part was the timing OMC, one of the oldest names in boating, threw everything at FICHT to stay competitive against Yamaha, Mercury, and Honda. They spent heavily on marketing, tooling, and dealer training. But the tech wasn't ready. The field failures were catastrophic, and the lawsuits piled up faster than warranty. Claims. In December 2000, OMC filed bankruptcy after 115 years. FICHT warranty claims were a major factor, and part support collapsed overnight when Bombardier bought the scraps. One owner faced 4 EMM replacements, totaling $10,000 in 18 months before the port engine seized completely. And the Marine Surveyor's report said, recommend complete repower. These engines are not economically repairable. Thousands of boats sat on lots and in driveways with perfectly usable hulls and 3.3-liter FICHTs no buyer wanted to touch. Thousands of boats abandoned in yards, FICHT became a curse word, and they still appear in ads saying just needs minor work. And the brutal part, those V6s weren't even the full extent of the damage, because FICHT didn't just ruin one model, it poisoned an entire lineup. Number 1. Johnson Evinrude FICHT Ram. All models. The complete disaster. This is the same engine family as number 2, but it deserves number 1 because it didn't just fail, it killed its own manufacturer. Every single model from 90 to 250 horsepower had catastrophic problems. Smaller FICHTs shared the same core issues as the big 3.3-liter motors. Fragile electronics, injectors that could melt pistons, and software that sometimes delivered dangerously lean mixtures. OMC rushed direct injection to market before testing was complete, kept selling while field failures mounted, and couldn't fix problems fast enough. Warranty claims bankrupted a company that had built engines since 1885. There is no current market value because they're worthless. Free boats with FICHT power are still too expensive. When these engines failed, they failed completely. Injector failure caused detonation and melted pistons. EMM failure meant no spark and boats stranded offshore. Sensor failures created wrong fuel mixtures that seized engines. Dealers were overwhelmed with warranty repairs they couldn't fix. Parts were back-ordered for months. Updated fix kits and software flashes arrived late and inconsistently, and even engines that survived updates carried the stigma of the name on the cowl. Customers sued. Dealerships closed or dropped the brand entirely. Some longtime OMC dealers watched 30 or 40 years of brand loyalty evaporate in a few seasons, as angry customers demanded buybacks, refunds, or repowers. Real families were stranded 40 miles out when both engines quit and needed Coast Guard rescue. Used boat buyers learned to scroll past any listing that said Johnson or Evinrude FICHT, unless they were planning to budget for a full repower. One owner watched a piston punch through the block at wide open throttle after 340 hours, total loss, no repair possible. Another said his pair of brand new FICHTs never made it past the first season. They looked modern, they sounded powerful, but they were grenades with paint. In some marinas, FICHT cowlings were literally removed and the engines were parted out to hide what they used to be. Salvage yards stacked FICHT powerheads because there was no economical way to bring them back. The FICHT destroyed thousands of boats, hundreds of dealers, millions in owner investments, and a 115-year-old company. No other outboard has caused this much damage. It isn't just the worst engine line on this list. It's the benchmark for how badly a marine launch can go wrong, and a permanent warning for anyone who thinks unproven technology and rushed testing are a good combination on the transom. These aren't just bad engines, they're financial disasters that ruined families and killed companies. If you're shopping used, research the specific model and year. Check owner forums, not spec sheets. If the price seems too good, there's a reason. If the seller says, just needs minor work, walk away. A $3,000 discount becomes a $10,000 nightmare. Own one of these? Share your story below. Did this save you from a mistake? Hit like and subscribe. And next week, we'll show you the new outboard motor from Mercury that will change boating forever.